Hello everyone, Greg here, and we are talking about eddc608 week 5 today. Two primary topics, two sample t-tests and one-way ANOVA. And last week we talked about a one sample t-test. Well, here is how a two sample t-test works. Let's say we want to compare two groups. So we want to know if the mean of the lengths of the cat's tails in Oregon is the same as the mean of the lengths of the cat's tails in Washington, or two groups of test scores, whatever. So we take a sample from each population, and our sample includes a sample size, a sample standard deviation, and a sample mean. Size, mean, standard deviation. Now, it's with those two samples that we can determine whether there is a statistical difference in the population means or not. Meaning, these two samples have to be such that our null hypothesis is that the population means are the same. Okay? So we take two samples, and it's from those samples that if they have the right information, we can reject the null hypothesis that the population means are the same in favor of the alternative, or what's called the research hypothesis, that the samples are different, or that the populations are different. Now, let me give you some examples. You can compare any two populations by taking samples from them and using a two-sample t-test to determine whether you can reject the null hypothesis that the population means are the same. What is commonly done in research is, if you have a control and an experimental group, and your control group is essentially a sample from the population of all students who wouldn't be given a certain treatment, we use the word treatment, but maybe a teaching method, and the other sample would be from the population of, if you gave that teaching treatment method to all of the students in the population, because you remember, when you're selecting two random groups, you're only selecting samples. So what you would want to do is conduct a two-sample t-test to see initially if the groups were equivalent. And so you would want to have a p-value that is very large. Okay? And the reason for that is because you do not want to reject the null hypothesis that the groups are the same, because then your experiment is invalid. You want to start out with equivalent groups. Now, at the end of the experiment, you would test the two groups, the treatment group and the control group, and you would want to find a very low p-value, let's say 0.01, because then you can reject the null hypothesis that the two groups are the same in favor of the alternative that they're different. And hopefully they're different because the teaching method that you gave to the experimental group made a statistical difference. So that's the main reason that you use two-sample t-tests in research. And you will find that in several of the studies that we have. Okay, so just for example, I've used the here's the calculator that's in the text, the two-sample t-test calculator. And what you do is you simply enter the mean, standard deviation, and sample size of each of the two groups, and you click calculate, and it gives you a p-value. Now, in this case, our p-value for these two samples is 0.0105. That means we can reject the null hypothesis that the mean of these two populations is the same based on the sample. Okay? And that's all you have to do to conduct a two-sample t-test. Calculator is very easy to use. So practice that two-sample t-test with these numbers. The next test we're going to do today is called the one-way ANOVA. And a two-sample t-test is only used for two populations. The one-way ANOVA can be used for 3 or more populations. And what it says is, the null hypothesis says the mean of one population is equal to the mean of the second is equal to the mean of the third. And so we could be comparing, let's say we took a sample of SAT scores from seniors from three or more different high schools. And we wanted to see if the mean score in all those different high schools was the same or different. So our null hypothesis would be that the mean from those three populations, those three groups of seniors from the different high schools, were the same. Now the one-way ANOVA test is extremely complicated, but using the calculator is very simple. So let's say we put in some numbers, and when you go to the calculator, it asks you first of all for the size, for the number of samples, and in this case that's 3. Now here are the sample values I put in. 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. That's the numbers from one sample. Just that for you. 4, 5, 6, 7, 8. 9, 10, 11, 12, 13. 9, 10, 11, 12, 13. And 20, 21, 8. 20, 21, 8. 10 and 9. Okay, so let's say these are the numbers on a certain examination from a sample from high school 1. These are the numbers on a certain examination from high school 2. This is the sample. This is the sample of numbers on a certain examination from high school 3. Our null hypothesis would be that the mean of those scores in all the populations is the same. Well, the one-way ANOVA test lets us compare 3 groups, not 2. Now, here is what the one-way ANOVA output looks like when we have put the numbers in. And as you can see, the p-value is 0.0272. The p-value is 0.0272. Now this allows us to reject the null hypothesis that the mean of the test scores in all the groups is the same. What it does not allow you to do is tell you which of the means may be different from the other. It does not allow you to do that. All you know is that the 3 groups are probably not the same. That's the alternative, or that needs to be an HA. The alternative or research hypothesis. So a one-way ANOVA is fairly simple procedure. So is a two-sample t-test, and we will be working with those more this week. Okay, thank you.